Hi, everyone. I am Brian Chambers, the development director here at Foundry 42 Frankfurt. We started Foundry 42 Frankfurt a little over 2 years ago with 6 employees. This past month, we just signed our 7th member of the team, 7-0. We've come a long way in a short time from an office mostly filled with empty desks to now an almost full office working across most all disciplines. This past month has been busy as usual. At one point, we had, I believe, 15 visitors here from other offices working across various disciplines. We occasionally travel to the other offices to meet and discuss future plans, review progress in certain areas, kick off large tasks, etc. So let's jump right into it, see what the team's been working on over the past few weeks. Starting off with the weapons team, the FPS weapon artist finished a second art pass on the Klaus and Werner Arclight 2, the Gallant, and the Arrowhead. These now include new venting mechanisms which add much more visual interest when you're doing things such as reloads and so on. They also completed the first art pass on the Kastak Arms Ravager 212 and a second art pass on the Kastak Arms Devastator with an additional layer of detail. For the ship weapons, we completed all the rockets and rocket pods, ranging from size 1 all the way to 3, as well as the first art pass for the Knightsbridge Arms ballistic cannons. We can now use those various sizes to test out the new modularity system and various upgrade levels and combinations to see what we can come up with. In the office here in Frankfurt, we recently hired a lead lighting artist to work with our global lighting team. One of his first tasks was modular surface outpost and determining how we'll integrate lighting in such a way that it feels coherent across potentially countless permutations of the outpost layout. Every single room could have a different arrangement of props and objects, which then dictates where lights would logically be placed, as well as the specific theme or mood for that room that we're after. For example, crew sleeping quarters need to have a different mood than a hydroponics lab, etc. Our first step, though, is to integrate simple lighting variations into the procedural system so we can discover and solve any issues that may arise, such as light leaking through walls or certain lighting variations looking incorrect when placed next to each other and so on. Really see what conflicts. At the same time, these technical challenges, we're also focusing on creating a visual target for our main room types: habitation, hydroponics, engineering, storage. See how far we can push the lighting to match our concepts and goals for the interior look of our surface outposts. When these are finished, we can then determine how to break the lighting down into modular components that can then be fed all the way back into the procedural system and be applied to all the other procedural bits we have. The tech art team here in Frankfurt worked on multiple skinning tasks this month, including clothing for both the PU and Squadron 42 to widen the range of customer character customization, and a skinning pass on the final Vanduul mesh so the animators can work across on their animations. They worked on a tool for the animators to redirect their walking animations to turn animations. It's a fairly simple tool, but ultimately it'll reduce the time that the animators need to spend on creating those specific animations. In a sense, it allows us to reuse and recycle. They also created a tool to allow the team to quickly update the exact grip placements of individual weapons. Artists can now use a reference mesh, create an offset, hit export, and immediately see the changes live in Engine. This makes things much more efficient, allows them to iterate much more quicker than they did before. The level design team here in Frankfurt's busy working on the modularity of space stations and surface outposts, as seen in a recent ATV episode. As an initial proof of concept, we have 5 versions of the outposts that we're moving forward with. In the future, we'll be able to create a large number of outposts with different layouts and purpose, but as an initial step, we focus on just a few to ensure that the systems, props, placement of planets, blah, 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 all working together as we intend. The truck stop is our first test of modularity in space stations. We've been working on customizable hubs to be able to create variations using add-ons and procedural plot placement to add flavor to various rooms. The modularity of space stations also extends to how the rooms connect to one another following pre-made flowcharts. We're currently working with engineers to get it functioning in-game and get it all going the way we actually intend it to be. The system design team has been continuing their work on the usable system, as we've also recently discussed. They've also been working with the cinematics team and helping to establish the final look and feel that we'll have for the conversation system, and the progress is going good. For the engine team, we generally discuss what they've been doing for the procedural tech, and they've continued to make great progress there. But I thought I'd dig a little bit deeper into a couple areas this month. So yeah, here goes. We finally finished the physics grid refactoring, which is used to store each individual physical object in the world and to allow for fast neighbor queries, such as give me all the objects within 10 meters. And it has all the bells and whistles now active. The old legacy cryphysics grid system worked by projecting the entire world onto a fixed 2D array of cells of uniform dimension. For memory reasons, the old system was configured to huge cell sizes to allow for our massive worlds, which led to severe performance problems when dealing with lots of small objects, as well as lots of entities returned due to the fact that the grid would wrap around every few thousand kilometers. To address these issues, the new grid system was designed to have a sparse and fixed hierarchy of nested 3D grid cells of various sizes, where objects would get inserted into different levels of the fixed hierarchy depending on their size. We can therefore efficiently handle objects of the size of a planet, several thousand kilometers in radius, down to small pebbles just a few centimeters across. Initial performance tests, once it was in the Crusader, have proven the new grid to be vastly more efficient. 10 times less entities returned for small queries, and queries in general faster in the magnitude of 1.2 to 2 times, while using slightly more memory than our legacy system. On the animation front, our lead animation engineer, Ivo Herzeg, has been busy for quite some time. He's been building the core foundation of our AI movement. I want to give you some insight into his progress and give you some examples of what he's been working on. Most of our animations were motion captured, which is a perfect solution for cutscenes and all types of linear animations where things are fixed and predictable. But you can't use mocap data directly for animations that need to be truly interactive, like we'll have for both the player and the AI. To use the mocap data in interactive situations, we must break down the longer motion clips into shorter clips and generate multiple variations of the same motion style. As an example, for a simple walk cycle, we need walking at different speeds, walking in circles, walking on slopes, and walking in different directions such as strafing, etc. A typical AI character in Squadron might have about 1,000 of these small little motion clips. It's impossible to create unique animation clips for every single given situation. That's why we developed a blending technique that we call parametric blending, which enables all these clips to be controlled at runtime. Parametric blending takes the concept of simple animation blending and moves it to the next level. The goal is to make the outcome of the transitions, or an interpolation, predictable for an undefined number of assets. Each motion clip contains a combination of physical and stylistic properties. We call those the natural motion parameters because they're inherently part of the motion itself. To control a character in a game, we want to pass these natural motion parameters to the animation system and let it generate the motion we need itself. Once we have enough animation clips, we put them into what we call a blend space. The most important aspect of a blend space is that each animation clip represents a point in a coordinate system, and all points are connected by an index list. In a blend space, we treat blending as a geometrical problem. The geometrical relationship between the animation clips is extremely important for the blending to work correctly. And the placement of these assets into the blend space is set up so it's fully automatic due to how the animators set up their locators before they export their animations. In a single blend space, we can have more than 100 unique animation clips, and we can control all of them like a single animation. What you see here is an example of a 2D blend space. In this case, we put the travel speed on the X and the turn speed on the Y. We can move the red cursor over the plane, and for each coordinate, we get a blended motion with the correct parameters. This means we can generate all motions between a slow walk and a fast walk while maintaining the correct turn speeds. In this test area, we can move the cursor in any place or direction and always get the correct blended motions back. Here's an example of parametric starts and stops that lead in and out of the walk cycle. You can see how a character starts to walk in the direction we select, and then he walks at different speeds with different turn angles and stops to the left, right foot, left foot, etc. Blend spaces are not only limited to simple motion cycles, they can be used for most AI motions in our vast universe, enabling our AI characters to move fluidly and realistically throughout the entire world. It's great to see Evo's progress, and it's definitely going to have a strong impact on how our AI navigate around the world. The engine team also did improvements to the objects blending with terrain. The underlying terrain and object shapes are now taken into account to blend procedurally distributed objects more naturally with the planetary generated environment. And I hope to show you those improvements soon. The QA team here in Frankfurt grew by 1 member this past month, James Stevens, our new senior QA tester. He immediately stepped up and took charge of pioneering the testing of the loadout editor. The loadout editor is heavily used by our devs across all 4 locations, so it only made sense for us to increase the depth of testing we do for it on a daily basis. Melissa Estrada also spent some time testing the first version of the Solar System Editor, also known as SolEd. The engineers went over SolEd's functionality. We gathered initial feedback from the team. QA was there, they documented all the feedback, and now they'll work closely with the engineers to find the best way to address each item and how to test it and work with them in the future to get all those resolved. They also supported the engine team with testing of a few separate things, such as updated planet physics grid and refactoring of the texture streamer logic. The AI team this month completed some work on mission-related functionalities for both the PU and Squadron 42 designers. They also worked on improving the setup for complex conversation scenarios where multiple characters need to interact with one another. The first step to achieve this was to allow the subsumption logic to run on top of the players. This allows us to execute some logic on the players on predefined story scenes, but also make sure that the AI system can fully communicate with the player and interact with them. The subsumption tool, which you've heard a lot about, has also had some improvements on the conversation setup and kicked off work on what we call the conversation sub-activities. The sub-activities describe the logic for multiple characters in one view to make it easier for designers to synchronize interactions between the characters and the environment. Under the hood, these conversations will still result in unique sub-activities that will run on different characters so that we can still guarantee that each individual entity can still handle further events and situations on their own. They also completed the first pass on refactoring of the perception for spaceships. We currently have a general perception component on characters that can handle several types of senses. Normal human will obviously have things such as vision and hearing, but once sitting down inside a spaceship, they'll also be able to interface with that spaceship's radar and the group information about the different senses into its perception component. This will now allow us to progress easily towards more character control behaviors on spaceships, since we're removing strict dependencies between the game code and specific behaviors running on the vehicles themselves. Cinematics team, as always, is making steady progress across multiple chapters this month. Some implementing brand new scenes, some they're polishing existing ones. As I previously mentioned, I unfortunately can't show anything specific at the moment without spoiling anything, and they'll all yell at me. In the coming months, though, we're hoping to show you a few bits to really give you an idea on the quality bar that we've set. We've set the bar high for ourselves, and it'd be good to show that off in the work that we're proud of. VFX team here in Frankfurt is continuing working on planetary effects. The systems for implementation have been progressing nicely thanks to the close collaboration between the VFX artists and our engineers here. They started implementing some of the new effects on the planets, including various atmosphere and weather effects, as well as more specific effects for various types of assets that will be distributed with the object scattering system. The Frankfurt environment team has been primarily focused on finalizing the moons. The procedural asset distribution system has seen a lot of progress and is still improving. All the separate pieces that make up our procedural planets and moons are truly starting to fall in place, you could say, and things are looking great. So that wraps us up for Frankfurt. Thank you for all the support that everyone gives us on a daily basis. The team honestly, truly, really appreciates it, and I'll see you again soon.